Welcome to Mr. Maths, grade 12. Today we're looking at some factor theorems and long division. First of all, we need to understand what it means to factorize. So when I factorize, I've always got to consider the number of terms. So either I have 2 terms, what happens when I have 3 terms, and what happens when I have 4 terms. Now, it's pretty simple. You do them since grade 9, but just to recap, always start with the highest common factor. Irrespective of how many terms you have, you always want to see, can you take out a highest common factor? When you have 2 terms, the next option, if there's no highest common factor, you can look for dots, which is a difference of 2 squares, or you can look for docs and socs, which is basically difference or sum of cubes. So something like x cubed minus or plus or minus b cubed. The difference of squares is x squared minus only b squared. That's generally when you have 2 terms, those are the 3 things that you are looking for. If you have 3 terms, what you want to look for, if it's not highest common factor, a trinomial. Trinomials are generally in the form of ax squared plus bx plus c. And that's generally when you have 3 terms. There's not much else. Sometimes you have cubic functions, which are generally in the form of ax cubed plus bx plus c. So you're missing one of the terms, but that's not a common occurrence. When I have 4 terms, I'm always looking for highest common factor, or I'm looking for grouping, or alternatively, later on you look for cubic functions, which are in the form of ax squared or ax cubed plus bx squared plus cx plus d. Right, and that essentially is still possibly a grouping question, depending on what those coefficients are. And that is our factorizing. We always want to look for 2 terms, 3 terms, 4 terms, and we have certain rules for the different number of terms. What we've got to remember is the operation. I have multiplication, division, addition, and subtraction. The operation that's linked to factorization is division. So when I factorize, I'm actually doing a form of division. So with that being said, that division. Now, back in primary school, have a look. You learned how to do long division, and I'm just going to put this here for now. D, M, S, B. Depending on who taught it to you, some people like to say daddy, mommy, sister, brother, but basically it's division, multiply, subtract, and bring down. Now, just to remind you how it works, if I have 2,564 and I want to divide that value by 4, this is how long division works. So I say, can 4 go into 2? No, so I bring down the 2 and the 25. Can 4 go into 25? Yes, it goes in 6 times. So that's my division. 25 divided by 4 gives me 6. Then I move to multiplication. 6 times 4. So it's 6 times 4 gives me 24. I then subtract those, gives me 1. I bring down the 6, which then makes that value 16. And that's, I've been through the cycle, division, multiplication, subtraction, bring down, and I then repeat the process. Right, and so 16 divided by 4 is 4. 4 times 4 is 16. I subtract. What I have left, 0. Bring down my 4. So now I'm going to say 4. Can 4 go into 4? Yes, it goes in once. So 1 times 4 is then 4. Subtracted, and I get 0. Now, this 0 is a very important value, especially for when we're doing algebraic division. What does it mean when I have 0? It means that, well, firstly, that there is no remainder. So 4 goes exactly 641 times into 2564, right? Which in algebra means that the 4 and the 641 are both factors of the 2564, meaning that if I multiply those two, I get 2564, right? So this is a factor of 2564, and so is the 641. Now, I could break up the 641 into another number and give me more factors, but for the purpose of this, when I divide 2565 by 4, I get 641. If I do it the other way and I say 2564 divided by 641, I will get 4. So those are the pairs, the factor pairs. Now, how do we transfer this idea into algebra? Well, if I have 3x squared plus 7x minus 6, and I want to divide that by x plus 3, I follow the same procedure. The main difference is I only do the division with the x value. Everything else I multiply together. So let's have a look. I'm going to say 3x squared divided by x. So 3x squared divided by x leaves me with a 3x. Now when I multiply both values. So 3x times x gives me 3x squared, and 3x times 3 gives me plus 9x. So that's my division and my multiplication. Now I've got to do some subtraction. So I subtract both these values. So remember, this one's got to change into a subtraction. So 3x squared minus 3x squared leaves me with nothing. 7x minus 9x leaves me with negative 2x. And I bring down my 6. Now, to repeat the process, I'm going to say 2x divided by x leaves me with negative 2. I multiply again, negative 2 gives me negative 2x. Negative 2 times 3 gives me positive 6. Remember to subtract. So this turns into a positive and this turns into negative. Negative 2x plus 2x leaves me with nothing, and negative 6 plus 6 leaves me with 0. And there again we have that 0, meaning that x plus 3 is a factor of 3x squared plus 7x plus 6. So what do we say then? We say that if I had to factorize that trinomial, I end up with 3x minus 2. And that is the same idea as the 4 and the 641. They are both factors of 2564, and these are factors of that trinomial. So factorization comes from the idea of division, and here we have long division to deal with finding factors. Now, what happens if this value here is not a 0? Well, then it's pretty easy. Then you just add the remainder to the back. So let's have a look at this question. It says here completely factorize, and it's given us x cubed minus 12x minus 16. Right, on the right we're going to put some steps. The first step is to understand what the factor theorem states, or the remainder theorem states. And basically, so step 1, we're going to use the factor theorem. So what that says is it basically says that I'm going to find factors of the constant and factors of the leading coefficient. Right, so the leading coefficient is, in this case, 1, and my constant is negative 16. So the possible factors for 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 plus or minus 16, right? And the factors of 1, well, are pretty simple, plus or minus 1. Now, the theorem states that all my possible factors are b over a, right? So b over a is basically any factor of the constant divided by factors of the coefficient, and in this case it's our leading coefficient. So possible factors are, in this case, plus or minus 16, plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. So once I've done that, I'm going to test these values. Now, depending on how lucky you get and the values you pick, but essentially you're just going to substitute minus 1 into my theorem, minus 2 into my expression. Let's go with plus 1, and let's go with negative 2. So if I put negative 1 in, I get negative 1 cubed minus 12 negative 1, take away 16. In this case I have negative 2 cubed minus 12 negative 2. So let's just see what these values are. So negative 1. So negative 1 becomes negative 5. And this becomes 0. Just to finish off here, we get 1 cubed minus 12 times 1 minus 16, which in this case gives me negative 27. And the negative 2, that should be a positive 2, gives me 2 cubed minus 12 times 2 minus 16, which is then negative 32. So I've tested for, I could have just those and those, but I could have tested any combination of those. What is important is this one. Why? Because that means that negative 2, when x is equal to negative 2, my function is equal to 0. And that is what tells me x negative 2 is a solution. Therefore, x plus 2 is my factor. Make sense? So, what do I do with that? Well, now I'm going to take this, because I want to factorize, and I know that x cubed minus 12x minus 16 is my expression, and I know that x plus 2 is a factor of that. Problem that hopefully you see here is this is not in the form of x cubed plus bx squared plus cx plus d. I'm missing the x squared. So what I want to do when I'm going to deal with my long division is I want to just take these away. I'm going to just add in an expression for the x squared. So it's going to be plus 0x squared minus 12x's, take away 16. And now I can do my long division. So let's have a look. I want to say x cubed divided by x leaves me with x squared. Multiply them, x squared times x gives me x cubed, and x squared times 2 gives me 2x squared. Subtract them, this gives me negative 2x squared. Bring down minus 12x. Divide again, so negative 2x squared divided by x gives me negative 2x. Multiply them gives me negative 2x squared. Negative 2x times 2 gives me negative 4x. What I want to do now is subtract. So remember, when you subtract, the signs have to change. So those cancel out. Negative 12 plus 4 gives me negative 8x. Bring down our 16. We're going to say, let's go back to blue. negative 8x divided by x leaves me with that. When I multiply, I get negative 8x, and I get negative 16. When I subtract, remember to change your signs. So I get 0, and there we have again confirmation of that remainder. So what do I have now? I have x plus 2 and x squared minus 2x minus 8 are both factors of x cubed minus 12x minus 16. Something to remember, when they say completely factorized or fully factorized, it means I want only linear factors if possible. So x plus 2 is already linear. This is now a trinomial which I can factorize. So x and x, 8 is 4 times 2, and if I negative 4 plus 2, and there we have our fully factorized trinomial, in this case, three-termed expression, using the factor theorem and long division. And this is generally how I go about trying to solve. If it said equal to 0, what would I do? Or if I said find the factors or find the roots, that is what I would do. I would let this equal to 0 and solve for each of those x values. Now, just on that idea, where it says find the remainder when f of x is equal to 9x squared minus 3x plus 1. Now, something important, factors and roots are very closely related. The factor is basically what I'm being multiplied or being divided out, and the root is when I substitute the value of x and it gives me a remainder of 0 also. How did I get this? Well, I said 3x plus 2 is equal to 0. I had 3x equal to negative 2. Divide both sides by 3, and there is now my root. Right, so let's quickly just have a look. Negative 9x squared divided by 3x gives me negative 3x. When I multiply that, I get negative 9x squared. And don't forget to multiply by the second part of the expression, which gives me 6x. When I subtract, I've got to change these signs so that cancels out. Negative 3 plus 6x gives me just 3x. Bring down the 1. Now I'm going to say 3x divided by 3x. Be careful with this one. It's not 0, it's a division. So anything divided by itself leaves me with 1. When I multiply, I get 3x plus 2. If I subtract those, I remember that this must change to a subtraction. So that cancels out. 1 minus 2 gives me negative 1. Here you can see my remainder is not 0, which means that 3x plus 2 is not a factor of this trinomial, right? It's just a expression being divided by another expression. But the questions ask me for the remainder. So there the remainder is 1. That's through long division. Another way to do it is to substitute the root into the expression. So if I have to say negative 9 squared minus 3 plus 1, and what I'm going to do, I'm going to put this root in there and see what happens. This becomes negative 9 times 4 over 9 minus 3 times 2 over 3 gives me plus 2 plus 1. This 9 and that 9 cancel, so I'm left with negative 4 plus 2 plus 1, which gives me negative 1. And there we can see that these are the same values. All I've done is I've used long division for 1. And in this case, I've just substituted the root of that that factor. So here's a factor or a divisor, and we've said we've used the factor over there and we've used the root over there, and both of them gave us the same value. So what we can say is that f of minus 2 is equal to minus 1. That means that when x is minus 2 over 3, the output is 1. So that is my remainder when that is put into the expression. Or if it makes more sense to divide, because when you have division there are sometimes remainders, that is then also the minus 1. So through the long division I get minus 1 as a remainder. And that has hopefully cleared up some ideas of how to use the factor and remainder theorem, how to do the long division, and how to move between factors and roots. Join me next time for another episode of Mr. Maths.